The human eye undergoes extensive growth in the postnatal period. The average axial length of the neonatal eye is about 16.8 mm long, which is approximately 70% of the size of an adult eye. The fixation to target is well developed by around 8 weeks. Smooth pursuit movements are developed around 2 to 3 months. At birth, the visual acuity is between 20 by 400 and 20 by 800, and it reaches to 20 by 20, meaning normal vision is about, it will take about 18 to 13 months. The binocular vision is developed between 2 and 6 months of age. Accommodation is very limited at birth but improves rapidly over the first 6 months of life. Color perception is developed in the first 3 months, and the ability to match colors is well established around 2 years. Blink reflexes to light stimulus is developed around 30 weeks, and blink to a threatening stimulus is developed around 5 months of age. The human eye is an organ that gives us the sense of sight, allows us to learn more about the surrounding world than we do with any other 4 senses. We use our eyes in almost every activity we perform, whether reading, writing, working, watching television, and in countless other ways. The eye allows us to see and interpret the shapes, colors, and dimensions of objects in the world by processing the light they reflect or emit. The eye is a complex organ composed of many small parts, each vital to normal vision. The ability to see clearly depends on how well these parts work together. Hence, it is important to understand the various parts of the eye and its basic function. Eyelids are movable folds of the skin that protects the front surface of the eyes. They close the eyes in movement called the blink, which moisten the surface of the eyes and removes the debris. The eyelashes, also called cilia, are hairs that grows at the edge of the eyelids. They keep minute particles of the debris away from the surface of the eyes. The conjunctiva is a thin, transparent mucous membrane that lines the eyelids and covers the front surface of the eyeball. The section that lines the eyelids appears red in color because it contains many blood vessels. The section that covers eyeball appears white because of the cilia behind it. Light rays bounce off all objects. If a person is looking at a particular object such as tree, light is reflected off the tree to the person's eye and enters the eye through the cornea, the clear transparent portion of the coating that surrounds the eyeball. The light rays pass through an opening in the iris, that is the colored part of the eye, called the pupil. The iris controls the amount of light entering to the eye by dilating or constricting the pupil. In bright light, for example, the pupil shrinks to the size of the pinhead or to prevent the entry of too much of the light. In dim light, the pupil enlarges to allow more light to enter the eyes. Light then reaches the crystalline lens. The lens focuses light rays onto the retina by bending, refracting them. The cornea does most of the diffraction and the crystalline lens fine tunes the focus. In a healthy eye, the lens can change its shape or we can say accommodate to provide clear vision at various distances. If an object is close, the ciliary muscles of the eye contract and lens become rounder. To see a distant object, the same muscle relax and the lens become flattens. Behind the lens and in front of the retina is a chamber called the vitreous body, which contains a clear gelatinous fluid which is called as a vitreous humor. Light rays passes through the vitreous before reaching the retina. The retina lines the back 2/3 of the eye and it is responsible for the wide field of vision that the most people experience. For clear vision, light rays must focus directly on the retina. When light focuses in front or behind the retina, the result is blurry vision. The retina contains millions of specialized photoreceptor cells called rods and cones that converts light rays into electrical signals that are transmitted to brain by the optic nerve. Rods to provide the ability to see in dim light and cones the ability to see in colors. The macula located in the center of the retina is where most of the cone cells are located. The fovea, a small depression in the center of the macula, has the highest concentration of cone cells. The macula is responsible for central vision, seeing color and distinguishing fine details. The outer portion, peripheral retina, is primary location of rod cells and allows for light vision and seeing movement on the object to the side, that is called peripheral vision. The optic nerve located behind the retina transmits the signals from photoreceptor cells to the brain. Each eye transmits signals of a slightly different image and the images are inverted. When they reach the brain, they are corrected and combined into the one image. This complex process of the analyzing data transmitted through the optic nerve is called visual processing. The stabilization of the eye movement is accomplished by 6 extraocular muscles that attach to each eyeball and facilitates horizontal and vertical movements and rotation. These muscles are controlled by impulses from the corneal nerves that tells the muscles to contract or to relax, where certain muscles contract and other relax. The eyes moves. The 6 muscles and their functions are listed now. Lateral rectus. It moves the eyes outward away from the nose. Medial rectus moves the eye inward towards the nose. Superior rectus moves the eye upward and slightly outward. Inferior rectus moves the eye downward and slightly inward. Superior oblique moves the eye inward and downward. Inferior oblique moves the eye outward and upward. Visual acuity for distance and near vision. Visual fields, contrast sensitivity, color vision and depth vision are the 5 major functions of the vision. Visual acuity is a measure of sharpness or the ability of the eye to recognize a target in fine details is known as visual acuity. It is defined as the ability to read a standard text pattern at a certain distance, usually measured in terms of ratio to normal vision. 6 by 6 in meter or 20 by 200 in feet is considered as a normal vision. Distance visual acuity is measured by multiple ways. Snellen chart is a standard chart and is the commonest chart used in a clinical practice globally. Snellen chart can objectively measure visual acuity up to 6 by 60. If the patient is not able to read 6 by 60, then the chart is brought closer to the patient and vision is measured as 5 by 60, 4 by 60, 3 by 60, 2 by 60 and 1 by 60. If visual acuity is less than 1 by 60, then the presence of finger counting is assessed. Even when finger counts fails, then the patient's ability to perceive the shadow cast by the movements of examiner's hands in front of the eyes are considered. When hand movements are not perceived, then the perception of light is assessed in different quadrants. Landau's C chart and the Dumble E chart are similar charts substituting letters for the C or the E. Other test charts used are Bailey-Lowy logmark letter chart, lighthouse distance visual acuity chart, Finblum chart and Lea symbol chart. Near visual acuity is defined as the ability of the eye to perceive the size and shape of an object involved in near task. Example, reading. The ability to read N6 size print at 30 to 33 cm is considered normal near visual acuity. Reduced Shannon chart is the most commonly used near vision chart. Bailey-Lowy word reading chart, lighthouse number card, lighthouse near vision chart, Leah symbols are the other charts used especially in low vision examination. CS is a visual ability to see the objects that may not be outlined clearly or that do not stand out from the background. It is an important testing to measure the lighting requirements and other complaints in daily functioning. Persons with poor contrast sensitivity will have functional complaints such as problem in needle threading, coin identification, reading in dull print, need a great deal of light to read, experiencing tired eyes while watching television. Contrast sensitivity test measures the degree to which this ability has been lost, and it is measured through Pelly-Robson chart, Moss letter contrast sensitivity chart, Heidi low contrast face test, and low contrast visual acuity letter chart. Color vision is the ability of an organism or machine to distinguish objects based on the wavelengths of the light they reflect, emit or transmit. Color vision is possible due to photoreceptors in the retina of the eye known as cones. These cones have light sensitive pigments that enables us to recognize colors. Lack of light sensitivity pigments in cones results deficiency in perceiving one or more of the primary colors. Color vision deficiency is the inability to distinguish certain shades of colors or in more severe cases, one cannot see colors at all. Most people with color vision deficiency can see colors, but they have difficulty in differentiating between particular shades of red and green or blue and yellows. People who are totally color blind, a condition called achromatopsia, can only see things as black and white or in shades of grey, but this condition is very rare. This sensitivity of color vision deficiency can range from mild to severe depending on the cause. Color vision test indicates the level of difficulty in performing tasks that requires processing of color information such as matching clothes, coloring and recognizing traffic signals. Color vision is measured through tests such as Ishihara and Farnsworth dichotomous color arrangement test. The visual field refers to the total area in which objects can be seen in the side vision when eyes are focused on a central point. In other words, visual field is a degree of side or peripheral vision a person can perceive when looking straight at an object, in addition to what can be seen straight ahead. The visual field includes what can be seen above, below and to either side of the point the eyes are focused on. Visual field test determines the individual's entire scope of vision, that is, their central and peripheral vision. Visual field testing is important to detect eye diseases related to optic nerve and diseases affecting the visual pathways within the brain. Visual field is measured by many ways. Peripheral visual field is tested by confrontation, manual perimeter and automated perimeter. The integrity of central visual field is measured by Amsler grid chart. The term depth perception refers to the ability to determine distances between objects and see the world in 3 dimensions. To do this accurately, one must have binocular stereoscopic vision. Humans have 2 eyes and each eye captures its own view and the 2 separate images are sent to the brain for processing. Then, because of the 2 eyes are located in different positions, eye each takes in a unique view from its own perspective. The 2 separate images are sent on to the brain for processing. When the 2 images arrive simultaneously in the back of the brain, they are united into one picture. The combined picture appears 3-dimensional because it has a added depth dimension. That's stereo vision. Stereo vision gives you depth perception. If someone lacks stereo vision, they are forced to rely on other visual cues to gauge depth, and the depth perception will be less accurate. Depth perception is important to everyday life in so many ways. This ability allows moving through life without bumping into things. Depth perception is also helps in determining how fast an object is coming ahead. People who are one-eyed will often have problem in depth perception. The mostly commonly used stereo tests are Frisbee stereo test, stereo flight test and Randolph test. Principles of refraction. The optical system of the eye is a dynamic system, which on the basis of certain anatomical and physiological configurations can focus on multiple points through a process called accommodation. Refraction is a phenomenon which makes image formation possible by the eyes. Light rays are focused on the retina after refraction through the cornea and lens in a emmetropic eye. The corneal refraction power remains constant. The lens refractive power is modifiable with accommodation, and the axial length of the eye remains constant except under pathological condition. The far point is the farthest point that an eye can see, and the near point is the closest point which the optical system of the eye can focus on the optical system. Refractive errors. An eye that has no refractive errors when viewing distant object with an accommodation at rest is said to have emmetropic or clear vision. And an eye that has a refractive error when viewing a distant object with the accommodation at rest is said to have emmetropia or refractive error. As the eye grows after birth, there is growth of the eyeball and changes in the corneal curvature, axial length and length configuration. These changes compensate for each other so that the refractive power of the eye as a whole remains within a given range, thus enable the image to focus on the retina. If at any stage, if the process is disturbed, the image will not be focused on the retina and it leads to emmetropia or refractive errors. The primary symptom of refractive error is blurred vision for distant objects and near objects or distortion. Excessive blinking, rubbing and squeezing of the eye are the common symptoms of refractive errors in children. The common emmetropia or refractive errors of the eye are hyperopia, myopia, astigmatism and presbyopia. This is commonly known as farsightedness, hyperopia or hypermetropia. The focusing point falls behind the retina, resulting in straining to focus correctly, particularly at close distance. Therefore, the children can see well at distance but not near. Hyperopia can result from a shorter eyeball or a weak lens or a relatively flat cornea. There are blurred vision, especially when viewing near objects, trouble focusing when performing near tasks such as reading or chewing, frequent headaches and aching eyes and eye strains. The hyperopia can be managed or corrected with glasses using convex lenses of the required power or by contact lens or refractive surgery. The image of the distant objects is not focused on the retina but in front of it, making it appears blurred. A person with myopia can see objects that are near but not at a distance. Myopia can result from a elongated eyeball, a lens that is too strong or a cornea that is excessively curved. Blurred vision when viewing distant objects such as copying blackboard and recognizing faces. Myopia can be corrected with glasses using concave lenses of the required power or by contact lenses or by refractive surgery. Astigmatism is a type of refractive error in which differences in the curvature of the refractive media of the eye can result in the formation of images at two focal points. Depending on whether one of them is focused on the retina and the other is not, the corresponding sphere can be calculated. Blurring and distortion of vertical, horizontal or diagonal lines, eye strain, eye fatigue and headaches. Astigmatism is corrected optically with a cylindrical lens. Uncorrected astigmatism errors can be lead to amblyopia. Presbyopia can be defined as age-related loss of ability to sustain accommodation necessary for clear near vision. As one grows older, the accommodation ability decreases and it gets difficult to focus for near. It is a gradual process, starts at about the age of 40 and exhausted at the age of 60 years. Blurred near vision signals the onset of presbyopia. The symptoms reach significance when the person's accommodative amplitude becomes inadequate for his or her individual needs. Presbyopia is corrected by use of simple positive spherical lenses on top of the distance prescription. This is known as reading addition or ADS. You have understood the anatomy and physiology of human eye.